My name's Mike Tipton. I'm Editor-in-Chief of Experimental Physiology, and it gives me great pleasure to introduce our first podcast. And it's by Matthew Brothers, who wrote a viewpoint on the paper by David Filingeri et al., which was on Uthoff's phenomena, the influence of body temperature on the symptoms of MS.
Multiple sclerosis is a disabling disease that is characterized by demyelination of the central nervous system that affects approximately 2.5 million people worldwide. Individuals with this disease present with a wide range of symptoms, including fatigue, as well as impairments in vision, motor control, and bladder function. In addition, these conditions are exacerbated under conditions where individuals are exposed to elevated environmental and internal temperatures. This concept of heat sensitivity, originally termed Uthoff's phenomenon, affects approximately 60 to 80% of individuals suffering from multiple sclerosis, and accordingly has been the topic of research investigations dating back to the late 1800s. Interestingly, the majority, if not all, of this previous research has been focused on the efferent arm of the autonomic nervous system and primarily on in-organ responsiveness, while the afferent arm has been largely ignored. This is somewhat surprising given the known somatosensory abnormalities in MS patients. In addition, that ability to detect temperature changes, particularly at the level of the skin, is often our primary trigger to initiate behavioral thermoregulatory measures. In a recently published article in the Journal of Experimental Physiology, Filingeri et al. Utilized a novel approach to test somatosensory responsiveness to thermal stimuli applied to the dorsum of a hand in a group of individuals with relapsing, remitting multiple sclerosis and a group of control participants. The authors tested the ability of the individuals to detect the magnitude of 2 different hot stimuli and 2 cold stimuli before and after 30 minutes of cycling to elevate skin and internal temperatures, thereby initiating the Uthoff phenomenon. Given that the central and peripheral afferent pathways involved in the detection of cold sensation are myelinated, whereas those for the hot sensation are non-myelinated, the authors hypothesized that the sensation of the cold stimuli in the MS patients would be impaired while the sensation of the hot stimuli would be preserved. The novel findings indicated the thermal sensation to warm stimuli was similar at both time points between the groups of subjects to the warm stimuli. And in addition, the elevated internal temperature evoked by the cycling exercise had no effect on the sensation of the warm stimuli. In contrast, during the cold stimuli, the control group, they also had similar responsiveness to the 26-degree cold stimuli, both before and after exercise. So there was no effect of Uthoff's phenomenon on that more moderate degree of cooling. However, when the temperature was reduced to 22 degrees Celsius, so a much colder stimuli, the response in the control group was impaired. However, in the MS patients had reduced thermal sensitivity to both the 22 and 26 degree stimuli, indicating that there was an earlier onset of impairment in the afferent somatosensory function or detection of the cold stimuli in the MS patients. So this manuscript was selected to have a Viewpoint article written on it due to its novelty as well as the potential importance of the findings. Some of these importance could be related to the ability to provide support and maybe a methodological groundwork for a novel approach to assess afferent and somatosensory function in future investigations, not only in MS populations, but potentially in other populations where this could be an issue. For example, could this approach be useful in non-exercising situations, such as walking outside on a hot summer day? Another potential area of research could be centered on the effect of Uthoff's phenomenon on non-thermal stimuli, such as physical pain or visual stimuli. Are the responses to these stimuli also impaired in these patients? But I think probably, at least to me, one of the most important points of the paper, or potentially important impacts of this paper, could be in its ability or potential ability to determine the clinical utility of this non-invasive and easily implemented approach, for example, in the detection and diagnosis in MS, or perhaps to determine the disease progression or to assist in improving pharmacological and non-pharmacological treatment strategies and attempt to minimize the detrimental impact of this disabling disease. As a reviewer of the accepted manuscript, there are a few takeaways, particularly from the review process and the interaction with the authors in that process. I would say the most important is that the two reviewers, upon the initial submission, expressed that the authors could do a much better job in the introduction as well as in the discussion laying out the foundation, novelty, as well as the practical implications of the work. I believe that both reviewers felt that the importance of the work was not appropriately reflected in the initial version of the manuscript. However, the authors, in their resubmission, they did a wonderful job addressing these critiques on the resubmission. So in short, the authors should be commended for this innovative study, and they are encouraged to continue this novel and critically important line of research with the ultimate goal of improving symptomatology in individuals suffering from multiple sclerosis.